Welcome to Part 5 of the Evolution of Radiant Mixing presented by Taco. In Part 4 we examine Taco's iValve, a motorized three-way valve equipped with a fully functional outdoor reset control. Way back in Part 3 we learned that a three-way iValve is best applied to smaller jobs with lower flow rates due to its pressure drop or CV rating. Now in Part 5 we're going to take a look at two iValve options that can be used to overcome those pressure drop limitations: the four-way iValve with reset and the unique two-way iValve with reset. Let's get to work. We've seen that the three-way iValves, both set point and reset, are perfectly applicable for smaller radiant jobs, or even for zone-by-zone reset. However, it's the relatively low CV rating of the three-way valves that may limit their use. For instance, say you have an entire first floor with consistent floor coverings, consistent heat loads, and consistent water temperatures. Zone-by-zone reset may not be needed, but it might be beneficial to reset the entire first floor temperature. Now here's where the four-way valve could be of use. There are two major differences between the three-way valve and the four-way valve. Well, the first one's obvious. The four-way valve has one more hole, so the piping will be a little bit different. In addition, the four-way valve has much higher CV ratings than the three-way valve does, and therefore can handle much higher flow rates. The 3/4 inch four-way valve has a CV of 7, meaning it takes a flow rate of 7 gallons per minute through the valve for the valve to impart 1 psi of pressure drop, while the 1-inch valve has a CV of 9.3, meaning 9.3 gallons per minute flow across the valve are needed for 1 psi of pressure drop. The four-way iValve is available in both reset and set point applications. In fact, it uses the exact same actuating head as does the three-way valve. Valve wiring will be exactly the same as well, and because of the torque capabilities of the actuator, it is important to note that you must pipe the four-way valve in a primary-secondary manner. Here we show the proper piping arrangement for the four-way valve. Note the primary-secondary piping configuration and take special note of the fact that there is no circulator between the primary loop and the four-way valve. Because of the piping arrangement, none will be necessary. And also make sure to avoid putting a four-way valve in line in the primary loop. The primary circulator will create too much direct pressure on the iValve for the actuator to work properly. Let's take a look now at how the higher CV rating of the four-way valve will impact circulator sizing. Now previously, using the three-way valve with a radiant system that required 6 gallons per minute and had a head loss of 5 feet through the radiant tubing, when we used the three-way valve, we wound up with 14 feet of head total, and that required a 0011 or even a 0014 to do the job. However, if we use the four-way iValve, as you will see, we could use a much smaller and much less expensive circulator to get the job done. Now remember that the radiant system required a total flow rate of 6 gallons per minute, and there was 5 feet of head for the radiant tubing. At 6 gallons a minute, the hard piping for the radiant system needed to be 1 inch, and we also note that there's about 10 feet of that 1-inch piping. Using our head loss formula, we come up with about 6/10 of a foot of head for that additional 10 feet of piping. Now let's take a look at the four-way valve, and let's see what happens if we were to use a 3/4 inch four-way valve for this job. The flow rate that was required through the valve was 6 gallons per minute, while the CV of a 3/4 inch valve is 7, meaning that a flow rate of 7 gallons per minute through the valve would create 1 psi of pressure drop or 2.31 feet of head. Well, as we can see, the actual flow rate through the valve is less than that. It's only 6 gallons per minute. To find the head loss at the actual flow rate, we simply divide the flow rate of 6 by the CV rating of 7. We square that, and we come up with about 0.74 psi of pressure drop. To find the head loss using that number, we simply multiply 0.74 by 2.31, and that comes up with 1.7 feet of head through the valve. If we were to add it all together, we would arrive at 7.3 feet of total head for this job. So which circulator would we be using? Well, it's 6 gallons per minute and it's 7.3 feet of head. We look at our chart and we see that a Taco 007 or Taco 008 would handle the job very nicely. But why wouldn't you use a 1-inch valve in this application, since all of the hard piping is 1 inch? Well, you could use the 1-inch valve, but there are a couple of compelling reasons to go with the 3/4 inch one instead. The 1-inch valve has a CV of 9.3, and at a flow rate of 6 gallons per minute, that valve will impart only 1 foot of head on the system. Now compare that to the 1.7 feet of head for the 3/4 inch valve. That's not really a very big difference. Ultimately, you'd wind up using the same circulator anyway. So in this example, it might make sense to use the less expensive valve. In addition, the smaller valve will tend to give tighter water temperature control, since the valve won't have as wide of a hunt. As a rule, it's always best to size the valve by closely matching the flow rate to the CV valve rating rather than by the line size. It'll work out better that way, and it'll save some cost on the job. The iValve is also available in a two-way version in both reset and set point. The two-way valve can be used as an injection mixing control valve, and we'll explain that application in just a minute. The main advantage of the two-way valve over the three-way valve is that it has a higher CV rating. The half-inch valve has a rating of 4.9, the 3/4 inch 10.3, and the 1-inch 8.9. Much higher CV ratings, much lower pressure drops through the valve, and those low pressure drops make the two-way valve very beneficial for use in higher flow rate situations. Here's a piping arrangement for the two-way valve as an injection mixing valve. We can call this injection mixing without an injection circulator. Again, we pipe up the radiant in primary-secondary fashion using the two-way valve to feed the radiant. The two-way valve will open and close as needed to mix the appropriate radiant supply water on the other side, with some of the return water being piped through the bypass through a partially closed globe valve. The biggest benefit of using a two-way valve in this example is that we can use a much smaller valve. The rule is, of course, size the valve to the flow rate and not the line size. Now here's a look at that same radiant job we've been working on. 6 gallons per minute with 5 feet of head in the radiant tubing. Now to pipe this up with a two-way iValve, the hard piping from the bypass onto the radiant manifold would need to be 1 inch to handle the 6 gallons a minute. But the piping from the primary to the bypass, as well as the two-way valve, can be much smaller. Why? Well, that's the beauty of injection mixing. We're only mixing a small amount of hot boiler water from the primary to keep the radiant system water at the desired temperature. And the math is pretty simple too. Using our example of a 30,000 BTU radiant system sized to a 10-degree delta T with a supply water temperature of 135 degrees, we would find the injection flow rate by using the universal hydronics formula. That is, GPM equals BTUH divided by delta T times 500. In this case, the BTUH is 30,000. But the delta T is the temperature difference between the water coming into the secondary off of the primary loop, 180 degrees in this example, and the return water heading back to the primary loop. In this case, it would be 125. So the math would look like this. GPM equals 30,000 divided by 55 times 500. 55 times 500 is 27,000. If we complete the equation, the injection flow rate would be 1.09 gallons per minute. At that flow rate, half-inch pipe and a half-inch valve would be perfectly adequate. Now, if we calculate the actual head loss through the half-inch valve with a CV of 4.9, we would find that the head loss through the valve is only 0.11. If we added all of the additional head loss together on this job, the total head loss would be roughly 6.5 feet of head. With a flow rate of 6 gallons per minute, a 007 would be perfectly adequate for this job. The entire Reset iValve family has several additional features. Using the dip switches on the side of the control head, you can set both minimum and maximum radiant supply water temperatures, as well as a minimum boiler return temperature for boiler protection. It can be set to either 120 or 135 degrees, and it can be disabled by simply not installing the boiler return sensor. The warm weather shutdown function also has two options, either 70 degrees or it can be turned off. Well, that wraps up another Taco online training presentation. We hope you found the evolution of radiant mixing helpful, and please be sure to take advantage of the other Taco training presentations available on this website. I'm John Barba, and thanks for joining us.